I joined the Hebrew University 3 years ago. I came from Yale University, and here I established my lab on complex photonics, where we study how light interacts with complex media. What we are interested here in the lab is to really understand the fundamental properties of light and how we can use them to advance science and technology. Light is really the primary way we're sensing the world around us. It's the way we communicate over long distance. And what's remarkable is that every time there was a breakthrough in the understanding of what is light, immediately afterwards came in applications that are related to light. One remarkable example is the invention of a laser. Once people understood how light interacts with matter, immediately afterwards they realized how we can make a coherent radiation of light, and laser really revolutionized technology in the way we couldn't even imagine before. What we're trying to do here is to understand the quantum properties of light. Let me give you one example of one of the projects we're working on that I'm really excited about. So one of the biggest threats on modern society is the safety of communication, or in cyber attacks. It turns out that within a few decades, scientists, we believe that all the encryption methods we're using nowadays won't work anymore. And that's because at one day we'll have a quantum computer that will be able to hack all the algorithms we know of today that encrypts on data. What we're working on here is on developing the next generation of encryption methods that will be resilient against such attacks of a quantum computer. We're doing it by using the really fundamental properties of light. We're sending really single photons through optical fibers, and it turns out that quantum mechanics guarantees us that if we're communicating, if we're talking over some fiber optic and someone is trying to listen, we will always notice that he's there. That's the basic idea, and really it's going to revolutionize the way we send information to each other. Another project we're trying to do is to develop methods that will improve the resolution of microscope and cameras, so we can get sharper images. My lab is part of the Quantum Information Center here in the Hebrew University, which is one of the leading quantum information centers in the world and the first that was established here in Israel. So for me, when I came back to Israel, it was natural to join here the Hebrew University and be part of this amazing center, because it's a wonderful platform to collaborate with other researchers here inside the institute and also around the globe. We have a joint project with Yale University, where I did my postdoc, and the University of Central Florida. I welcome students and postdocs from all over the world to come and join us and get engaged in our research on quantum properties of light. And I think what's unique in doing science here in the Hebrew University and part of the Quantum Information Center is that we're very open, and the kind of research we do is very dynamic, so there's lots of room for the postdocs and for the students to bring in their own angle. I really welcome that, and I encourage them to do so, because I think the best ideas come from the students and the postdocs and the dynamics between them.